Assalamualaikum warahmatullahi wabarakatuh and a good day to all of you. So my name is Sharul Nazir Anwar. So I will be teaching the next chapter, which is chapter fault tolerance. So in order for us to understand about fault tolerance, we must first understand what it means for a distributed system to tolerate fault. So fault tolerance is strongly related with to a dependable system. So to hence the reason why we need to understand about the dependability concept first. So the concept of dependability, a component will provide services to clients. So basically, component here can be many things. It can be network services, it can be servers, it can be systems. So a component can provide services to clients. So basically, here, think of the component like a layered architecture, like for example TCP/IP or OSI. So to provide services, the component must require the services from other components, and a component may also depend on some other component. Like again, I said, think of it like a layered architecture. So if a layer is required to provide services to another layer, so they must provide that. So specifically, a component which denotes as C depends on other components which denotes as C star. So if the correctness of C's behavior, the first component's behavior, depends on the correctness of other components' behavior, so basically the components are processes or channels. Um, Now, next, let us look on the several aspects of dependability requirements. So dependability covers several requirements for distributed system. That is, first of all, the availability. Second, reliability. Third, safety. Okay, let me go for the point option. Third, safety, and lastly, maintainability. So under availability, we can explain it by saying that availability is the readiness for usage, but the readiness must be immediate readiness, meaning readiness to be used immediately. So next, the reliability. So reliability is continuity of service delivery, and then safety, which is the system must have a very low probability of catastrophe or damages if failure happens, and then maintainability, which is how easy the failed system to be repaired. Meaning, when we develop the distributed system, the system must be able to be repaired. So if we talk about the two of the main component of the dependability, main requirement of dependability, which is reliability and also availability. So reliability, which denotes as RT, so it's a probability that a component has been up and running continuously in the certain interval of time. So this is the certain interval of time. So we need to make sure that the given component was functioning correctly at time 0, for example. So there are a few traditional metrics that we can use to measure reliability. The first one is the MTTF, mean time to failure. It is the average time until a component fails. And then second is mean time to repair, which is the average time needed to repair a component. And lastly, mean time between failures, which is simply we add up MTTF and also MTTR. Next, let us look at the requirements of another requirements of a dependability, which is availability. So for the availability of AT, so this one AT is the apa is the average Okay, 80 is the average here. So basically, the average fraction. So the average fraction of time that component C has been up and running in interval 0t, meaning at time 0. So if we talk about the long-term availability here, so in long-term availability, it can be seen as how do we extend this interval, I mean the 0t, into infinity. Okay, and we look at the average time it is up and running. So here we need to understand that the reliability and availability can only make sense only if we have an accurate notion of what a failure is, meaning you actually knows that the failure will occur. So a distributed system is said to be failed if it cannot meet its function or what the system expected to be delivered. So for example, if a distributed system is designed to offer 10 services, so here failure means that the system fails to deliver or provide one of the service. So next let us see the differences between these three terminologies. So these three terminologies is the terminologies that we always use to describe failure. So, the first one is failure itself, which means a component is not living up to its specification. And then, for example, the failure is crash program. And then we have error. Only part of the component that can lead to a failure, like for example programming bug, meaning it will not make the system to stop operating completely, but it's only part of the component. And then the lastly is fault. Fault is the cause of an error, like for example the programming bug happened because of the sloppy programmer. So in order for us to handling fault in distributed system, when we want to develop a dependent system, it's very much relates to how we can control the fault. So when we talk about fault tolerance, the most important issues is fault tolerance itself, which is the system must still be able to provide service even with the presence of faults. So, for example, for packet transmission, each packet embed with the pairing bit, for example, the error correcting code also that is used to correct the packet transmission if there is problem. So basically, um, in handling fault, so there are few things that we need to focus on, which is the first one is fault prevention, which is we need to prevent the occurrence of fault in the first place. So don't hire sloppy programmers in the first place. We must rigorously do some rigorous recruitment for the programmers. Second, fault tolerance, which we need to build a component such that it can mask the occurrence of the fault. For example, build each component by two independent programmers. So the third one is the fault removal. We need to reduce the presence, number or seriousness of a fault, meaning if something happened, if fault happened, then we need to get rid of the sloppy programmers. And then the fault forecasting, where we estimate current presence, future incidents, and consequence of faults. So we need to also estimate how a recruiter is doing when it comes to hiring sloppy programmers. So to understand seriousness of failures, so several classification can be looked at. So for example, the first one, this is the classification that has been presented where we can divide it into four main type, which is the crash failures, omission failures, five main type: crash failure, omission failure, timing failure, response failure, and also arbitrary failure. So for the crash failure, it means that the server prematurely halt, but it is working correctly until it halts. Okay, so under omission failure, so basically we have two different categories under it, which is the receive omission and also send omission. So for what it means by omission failure, it means the servers or the systems fails to respond to incoming requests. So under receive omission, the servers fails to receive incoming requests, and under send omission, it fails to send messages. So basically for the receive omission, basically the server are not aware of the failure itself, because they do not know that they need to receive some incoming message. Um, so when they never get the request in the first place, so it may be the case that the connection between client and server is correctly established, but there was no threat listening. But for the send omission, maybe server has done its work but somehow fails in sending response. So when we say fails to send message, so basically the there's high probability that the servers already finished complete their work, okay, or the request message, but they fail to send in the response back to the client. And then we have the timing failure, which the response lies outside a specified time interval. And then under response failure, we have response failure means that the response is incorrect, not the correct value, or so not the correct value, or there is a failure in a state of transition. So basically, under response value, there are two types, which is the value is wrong, the response value is wrong, and then another one is the response deviates from the correct flow of control. Finally, we have arbitrary failure, or also known as Byzantine failure. So under arbitrary failure, what happened is the servers may produce arbitrary responses at arbitrary times, uh, but but which cannot be detected as being incorrect. Now, arbitrary failures, I mean the last failures that I have mentioned, are sometimes qualified as malicious. Yeah, qualified as malicious, meaning malicious is the effect, the catastrophic effect, how damaging it is, right? So it can be less damaging, but it could also be very damaging. So it is better to make the following distinction. First, omission failures, where a component fails to take action that it should have taken. And the second one is commission failures, meaning a component takes an action that it should not have taken. So the things with the um, omission failure is we need to judge that whether the failures is deliberate, be it omission or commission, and usually when the failures is deliberate, so there are typically security problems. So distinguishing between deliberate failures and unintentional ones in general is impossible. So now when we are describing about the halting failures, which is part of the um, discussion on um, omission failures, so arbitrary failures. So basically, imagine that component C no longer perceive any activity from other component. So is it really a halting failure? So as a system administrator, so basically we need to distinguish between a crash or omission or timing failure may be impossible. So many cases of failure deal many cases of failure deal with situation where a process no longer perceive any activity from the other process. So, however, can a process A, for example, conclude that process B, when they do not perceive any activity from process B, has come to halt or crash. So therefore, we need to differentiate between two type of distributed system, which is synchronous and also asynchronous. So basically, in asynchronous, so there is no assumption about process, speeds, or message delivery times, whereby we cannot reliably detect crash failures. But in the synchronous system, the process execution speeds and message delivery times are bounded. By saying that the message delivery time are bounded, meaning we know the system has crashed because they has exceed some certain time limit that has been preset. Okay, so because of that, we can reliably detect omission and timing failures. But we need to understand that in actual practice, in the real world, we need to there is no perfect synchronous system in the real world. So because therefore in practice we only have partially synchronous system. Most of the time we can assume the system to be synchronous. Yet there is no bound on the time that a system is asynchronous. Meaning, we can normally reliably detect crash failures. So basically here, uh, we need to understand the we need to understand that there are assumptions that we need to address because in practice we need to design fault tolerant solution that can withstand incorrectly detecting that a process has halted. So the analogy is like you are waiting for a friend in a coffee shop. So in synchronous system, in synchronous world, if your friend are not there at 5 p.m. sharp, so you know the friend, something happened to your friend, right? Maybe they have been kidnapped. But in the real world, we allow this some deviation from the set time. So if your friend um, does are not arrive have not arrived at 5 p.m., so you have to decide, do you need to leave because they are 15 minutes late, or do you need to stay because they just might be stuck in a traffic. So this is the decision. The analogy, my analogy is the decision that a system represent, the decision that the system must make uh, in deciding whether crash or failure, healthy failures already happened. Okay, so basically there are few assumptions that we can make because heart failure can be categorized as follows. So from the where the order is from the least severe to the most severe damage, yeah? So that we can see how robust the distributed system is. So we have the fail stop halting type, which is a crash failure but reliably detectable. So this one is a gentle crash, meaning a server or a system, for example, a server or a system send a dying gap signal, dying gap alert to network controller due right when the power supply fails. So this is the example. Okay, and then we have the fail noisy, crash failure, eventually reliable detectable, and then we have fail silent, omission or crash failures, where clients cannot tell what went wrong. This one is fail silent is kind of like false suspicion. Okay, so for example, OS kernel panic that freeze entire OS, but the but it's not necessarily that the system crash, but it's only a false suspicion. And then we have the fail safe. It is arbitrary failure, but benign, meaning they cannot do any harm or less damage. And then we have fail arbitrary, which is arbitrary with malicious failures. So, for example, there's a glitch that there's a hardware glitch that basically change the bits in memory, causing server to tell the bank to transfer 1 million instead of 1,000 ringgit. Yeah. Okay. So um, failure masking. Okay. Failure masking is the concept. Okay, failure masking is a concept that hide the occurrence of failure from other process using redundancy technique. So there are three types of redundancy. The first one is the information redundancy. In here, we add extra bits to data unit so the errors can recover when bits are garbled. So this is very clear in networking. So you have the frame, right? So you have the frame, so you add the error correcting code or having code added to the frame, to the frame, so that um, um, on the data unit part. So we added bits there so that the transmitted frame can be recovered from noise on the transmission line. And then second is the time redundancy. So we design a system such that an action can be performed again if anything went wrong. So this is typically used when faults are transient or intermittent. So that, for example, in your programming, so you put a board or and, right? So basically this is time redundancy. And then finally we have the physical redundancy, where we add equipments or processes in order to allow one or more component to fail. So this type is extensively used in distributed system. So I'll stop here now and we'll continue in the next video.